Okay, welcome back to part 2 of the counting principle question that we are doing today. So 12.2.3, the very last question. This is quite complicated, so I decided to do a separate video just on this one. They're saying that we need to calculate the probability that a poetry book is placed in the first position. Now, if we go back up to the given information, there are 5 different poetry books. So that means that for the first position, any one of those 5 books can be placed in that space. How many poetry books do we have left? 4 poetry books that are left when one of them are placed in that first spot. Then they're saying the 3 novels are placed next to each other. We'll talk about that in a while. But then they're saying a drama is placed in the last position. Now, if we look back, there are 4 different dramas. So that means that in the last position, that means that in the last position, there are 4 books that we can put there. That will leave us with 3 dramas that are left. Now, the fact that they've said that the 3 novels are placed next to each other, that means that they form a group on their own. So say, for example, they are in the second, third, and fourth spaces on the shelf. They can move to different spaces, but guys, these 3 books have to stay together at all times. So instead of having 3 separate books that can be arranged within these 10 spaces that we have left, we actually now have one group of books, one group of 3 books that cannot be separated. So when we are going to calculate the number of different ways in which these books can be arranged on the shelf, we are going to say 5, because there are 5 options for the first space, times 4, because there are 4 options for the last space. Then we're going to say how many books or how many movable objects are then left. Well, we have 4 poetry books, 3 drama books, and then 1 group of novels that cannot be separated. So 4 plus 3 is 7 plus 1 is 8. So there are actually 8 movable objects that can be arranged in these last 10 spaces. But guys, within the group of 3 books, because there are 3, they can also be arranged in 3 factorial different ways. You can have book 1, then book 2, then book 3, but you can also have book 3, then book 2, then book 1, and so on. There are 3 factorial ways for the 3 books, the 3 novels, to be arranged. So that is how many ways, or in how many ways rather, these books can be arranged if we are satisfying all of these conditions. But then if there were no conditions placed, if they could be placed in any position, it would be 12 factorial different ways for those. So if you just, and I'm doing that because they've asked for the probability, right? So we're taking the number of outcomes for this scenario over the total number of different ways in which these books can be arranged. You can then just use your calculator to work that out.